Alright, welcome to my YouTube channel. In this particular video, I want to show you how to calculate the total resistance and the current in each resistor in a series parallel circuit. As you can see, this is three resistors connected in series parallel, while one of the resistors is in series with two of the resistors are connected in parallel. So first of all, let's find the total resistance. Before we find the total resistance, we have to look at the parallel group. So the resistance in the parallel group. So we can make it RPG. So parallel group, RPG. So we underline and we say R, the resistance in parallel group is product over sum, that is R1 times R2, R1 times R2 over R1 plus R2, which is 7 times 13 over 7 plus 13. So let's find our answer. So our R in the parallel group becomes 7 times 13. So let's find the answer. 7 times 13. We find our answer. Our 7 times 13 is 91 over 7 plus 13 becomes what? 20. So 91 divided by 20. 91 divided by 20. We have our answer as 4.55 ohms. We have 4.55 ohms. All right. So as we have this answer, now let us redraw our diagram. So if we redraw, we are going to have our diagram like this. This is how our diagram is going to be like. So this will be the VT 120 volts. VT as the total voltage, and the R3 becomes 8 ohms. So let's say here becomes our R parallel group becomes 4. That is the answer we have here, 4.55 ohms. So now that we have these are now connected in series, as we redraw, so we say our total resistance is the R in parallel group that we have 4.55 plus the R3. So our total resistance becomes 4.55 being the parallel group and the R3 being 8. So our R total, which is the total resistance, becomes 4.55 plus 8 becomes 12.55 ohms. So now that we have our total resistance, we can now calculate for our total current. And mind you, our total current will be the same current that will flow in resistor 3. As we continue calculating, you will understand why. So total current is equal to amount of total voltage over total resistance, which our total voltage is what? 120 over the total 120 over 12.55. So our total current becomes, so let's check. Our total current becomes 120 divided by 12.55 becomes 9.56 amp. So therefore, because as we calculated this becomes the same amount of current that flows in R3. So this becomes our R1. That is the total resistance. That is the total resistance that they asked. That becomes, okay, so let me do it well so that you understand. So you see, they've asked us to calculate the total resistance as number 1. So this become as a number 1 total resistance. So here, number 2, they say current in each resistor. What they mean here is that they need the current that flows in 8 ohms, the current that flows in R1, and the current that flows in R2. Mind you that here, when the current flows from the series, when it comes here, part flow here and part flow here. So the current that flows here and the current flows here, when you add it, it will be the same current that flows in 8 ohm, which will be the same amount of total current. So therefore we say number 2I, current in our resistor 3, which is 8 ohm, is equal to what? 9.56. As we continue calculating, we will understand why. So let's find the voltage drop for R3. So voltage drop in R3 is equal to current in R3 by the R3. So voltage drop in R3 is equal to 9, so that is what is here, 9.56 by the R3, which is the 8, R3, which is 8. So voltage drop in R3 equal to, let's see, 9.56 times 8. We have our answer as 76.48 volts. Alright, so let's see the voltage drop in the parallel group. So the voltage drop in the parallel group, what we do is that we take the total amount of voltage, the supply voltage, and we subtract the voltage in R3, and we get the voltage drop in parallel group. So we say total voltage minus voltage drop in R3. So voltage drop in parallel group is equal to 120 minus 76.48. 76.48. So we say voltage drop in parallel group. So let's see the answer. 120 minus 76.48. We have our answer as 43.52 volts. Remember, when we add these two voltage, we should get the same amount of the total voltage. All right, as we continue, we will come back for that. So now let's look for our current, which is 2II. So let's look for our current in R1, which is voltage drop in parallel group over voltage drop in parallel group over the R1. So current in R1 is equal to voltage drop in parallel group is what? 43.52 over R1, which is 7. So current in R1 is equal to, so let's check, 43.52 divided by 7. We have our answer as 6.21 amp. So this becomes our current flowing in R1. So let's find 2II. So current in R2 is equal to voltage drop in the parallel group over the R2. So current in R2 is equal to 43.52 over what? 13. So our current in R2, so 43.52 divided by 13 divided 43.52 divided by 13. We have our answer as 3.35 amps. All right, let's add these two current. I told you that the current, that the total amount of current is the same current that flows in R3. So let's see, and the current that drops in R1, the current that drops in R2, when we add the R1 current and the R2 current, we get the same amount of current that flows in R3. So let's add the total current drop in what? R1 and R2 and see whether we'll get the same amount of what? The total current or the R3. So that we see that our answer is correct. So take your calculator and also check. So the answer 6.21. So you can also check 6.21 plus 3.35. We have our answer as 9.56 amp, which is amazing. It's correct. And let's check the voltage drop in R3, which is here, the series circuit, and voltage drop in the parallel group. Let's add it and see whether we'll get our total voltage. So voltage drop in R3, which is 76, that is this side, 76.48 plus voltage drop in the parallel group 43 plus 43.52. Exactly, we got our answer 120 volts. So you see that our answer is correct. Right, in the next video, I have another question that the resistors here are connected three of them are in parallel and one of them is connected in series. I will show you how to calculate the total resistance and the current in each resistor in that particular question. But for now, this is the answer for this particular question. Thank you so much. Subscribe, comment, and share my video. Go into YouTube, just write David Tete into bracket calculation and practice, and you see all this my calculation there. But for now, this is the answer for this. Bye for now. Meet you in another video. Bye.